Hi, my name is Rohan, and this is my medium ISP, the Autobox. The Autobox puts you into the optimal gear based on how quickly you're pedaling, and there's two modes, manual and automatic. So in manual mode, these two buttons are used up and down to go up down a gear or down a gear. This switch toggles between manual and automatic mode. So here's how, very quickly, manual mode works. Right now, it's in gear 5. Now we can go all the way back to gear 1, or actually gear 0, using these buttons. Then we can go 1, 2, 3, 4, and 5, and the gear set at the back will automatically adjust using a servo motor. Now in automatic mode, the display displays your cadence, which is how quickly you're pedaling, as well as changes gears dynamically. So this is a quick demonstration of how automatic mode works. As you can see, it's displaying the cadence in real time based on how quickly the pedals are moving. And it would also be dynamically adjusting the gears to correspond with that cadence. So here's how it works. The first thing to note is that there are actually 3 microcontrollers in this project. One in the actual Autobox, one in the buttons assembly, and one in the display. The main board keeps track of a reed switch to measure cadence and coordinates the actions of the other 2 microcontrollers over I2C. It tells the display what to show and compiles the data from the buttons. The buttons board continuously monitors the state of 2 buttons and a switch. Rather than send the state of the buttons, the board keeps track of the count between 0 and 5. When the main board requests the state of the buttons, it just sends the current count as well as the state of the switch. The main board then uses this information to determine whether it should adjust the gears based on the reed switch or from the value provided by the buttons board. Finally, the display has 2 onboard shift registers. All it does is shift out each of the 4 numbers stored in a buffer in quick succession, constantly, for a persistence of vision effect. The values in the buffer are controlled by I2C, by the main board. Using an independent microcontroller is arguably most important for the display unit because it allows the main microcontroller periodically to manage the display. For a 4-digit 7-segment display to work, the digits need to be constantly updated, which would take a lot of resources from other components, such as the main board. By having a dedicated controller, the main MCU can do other things while the display continues running. Now that we understand how each component works, here's how the device works as a whole. First, the main MCU requests the value stored by the buttons device. Then, it decides whether it should use the value from the reed switch or the user inputted value. If in manual mode, it simply moves the servo to the position stored in an array, based on the value received from the buttons device, then sends the gear number to the display. If in automatic mode, it measures the RPMs of the pedals from the reed switch. Then it compares the RPMs to the current gear, and then increases, decreases, or keeps the position of the servo the same. That's how my medium ISP works. Thank you so much for watching.